Here we're going to talk about linear equations and rate of change and solutions to linear equations. So you need to remember that linear line, notice the word line in it, linear equations are straight lines, and lines have a slope. Slope is synonymous with rate of change. So when they're asking you for the rate of change, you can calculate the slope. If there's a constant rate of change, that means the slope isn't changing. So that means that it has a constant slope, and that is a linear relationship. That's a straight line. Remember, slope, if you're given a graph, is rise over run. Slope is how far you're moving up and down over how far you're moving left to right. And if it's going down, it's negative. If it's going up, it's positive. So when you have a graph and they're asking which part of this graph has the higher rate, so if this is the cost per pound, higher rate means a bigger slope. Bigger slope means it is steeper. So you can easily look at that graph and see that the red portion here is the steepest. Or you could calculate the slope of each of these lines and see which one is the biggest. Either way, you will see that this portion from here to here has the highest rate. If you are given numbers in a table with x's and y's, or f of x is the same as y, and you were asked where the highest rate is, then you can pick 2 rows at a time and calculate the slope, the rate. So it's the change in the y's, so you subtract the y's from each other, divided by the change in the x's. So the 82 minus the 79 divided by the 13 minus the 11. So the rate between those first 2 rows is 11.5. The rate here is 3.5. So if they're asking, is this a linear relationship? It would be no, because the rate is different. It changes. If the rate continued to be the same, then it would have a constant rate, the same slope. Imagine it having the same slope, same rate, so that is a line. If it's not, then it is not linear. Here, it's asking, when did the temperature increase faster? They're asking, where is the higher slope, the bigger rate? So temperature and time. So T is time, and TT is temperature. So which is the X and which is the Y? So the TT, that's the function notation. That's another way to write Y. But also you can think of the fact that time determines the temperature. So this would be your X and this would be your Y. The X determines the Y. So now we're just going to look at 2 pieces of data at a time. Let's look at between 6 and 9, the time of 6 and the time of 9, and calculate the slope. And then you can look at between 9 and 13 hours after midnight, which is 1 p.m., and calculate the slope. If you do that, you'll see the slope between 6 and 9 is 2, the rate is 2. The slope between 9 and 1 is 1.5. So which one has a bigger slope? 2. So it's between 6 and 9. Solutions to linear functions. This is a question I've seen a few times on the state test. If they ask which of these points lies on the graph of the equation, there's two ways you can solve it. The first way is to use the graphing calculator. So you can graph the line and the points on the graphing calculator. So you can just put in, you're going to click this plus to add another expression over and over. So put in your equation, then put in each of the points in parentheses, and it's going to plot them. You're just looking to see which of these points is on the line. Which of these points is one of the many solutions that makes up this line. So that is one method. The other method is substituting in the x and y and seeing which one is true. So if you look at choice A and you put in 4 for x, multiply it by 1/2 and add 8 and see if it's 5. See if it gives you that y. If not, move to the next one. And if you're doing this, put this into your calculator to calculate it, to double check and make sure you're not making any mathematical errors. So see if that is 10. If you put this in your calculator, you are going to see that that equals 11. So the answer is C. When you put 6 in for x, the answer is 11. So that is one of the methods you can use. Or again, you could graph it. So why don't you try this one? If you graph this one, you notice one of the points is on the line, the red one. So the answer is 1, -4.25. Or if you put 1 in for x and multiply it by 3/4 and subtract 5, you're going to get -4.25. The last thing I want to show you is a question like this. This is again getting to the fact, making sure you understand that when you have an equation that has an x and a y, the equation is made up of points. These are x, y coordinates. These are solutions. If you put this x into the equation, it's going to give you this y. So this is asking, when you have a point where the x coordinate is 5, what is the y coordinate? So all you need to do is substitute this in for y, for x, and solve for y. So for a question like this, you need to remember this is our x coordinate and this is your y coordinate. When you substitute that in, you get 3 times 5 instead of x, minus 4y equals 18. And 3 times 5 is 15, minus 4y equals 18. And then you're going to subtract the 15 from both sides. And then you're going to undo that multiplying by -4 by dividing by -4. And our answer would be -3/4. On the state test, if you have a fraction, you can always change it to a decimal by dividing. If you have a fraction, you want to leave it as a fraction, just make sure you simplify. So if this was instead -9/12, you would have wanted to simplify that to -3/4. So always simplify your fractions if you're giving them, or change them to decimals.